Now question number 9, show that we have to prove that LHS which is equals to RHS. Okay, it means after simplification of from left side we must get answer what? 1. Okay, now let's start beginning this one solution for this. I'm just taking from the LHS now because we need to prove equals to 1. Now look at this question. See here, both bases are same. Okay, so what we can do, we can either break this bracket and we can apply a minus b for the both, or what we can do, we can just shift the denominator to the numerator. Okay, what will happen if you apply this a minus b to the both? No, it will take little extra step. Instead of what we can do, I'll shift this x raised to the power minus b to the numerator. As we know that if the power is in the negative form, we will make always a positive by doing the reciprocal. The same thing I'm doing here. Now let me send x raised to the power minus b to the numerator. When I'll send to the numerator, here it is division, it will convert to multiplication, and the power it gets plus sign, that is plus b. Okay, now it's bracket, that is a minus b. This point is nothing but multiplication here. Now similarly I'm doing for this 2 now. Now here I'll get x raised to the power b into x raised to the power plus c, bracket complete, and raised to the power b minus c again. Okay, now here x raised to the power c into, it's become now x raised to the power plus a, bracket complete, c minus a. Okay, now what we will do, both bases are same, so which law we can apply? We can apply the product law. So in the product law, what it says, when the bases are same, no, we can add the powers. Okay, now it will become a plus b according to the product's law. Okay, the same thing I'm doing here, b plus c, bracket complete, and here b minus c, and here c plus a, bracket complete, c minus a. Okay, now which law we are going to apply now? For this we will apply the powers law. Okay, so in the powers law, what we will do, we will multiply the powers with the powers. Okay, see here, now look at this ones, a plus b, a minus b is nothing but what? A square minus b square into x raised to the power, here we will get, that is b square minus c square, into here I'll get x raised to the power c square minus a square. Okay, now we must get answer 1, right? So what we will do now? Now we will split these powers to for x. So in that case, I'll get, that is x raised to the power a square into x raised to the power minus b square. We can do, yes or no? So when the bases are same, no, what we will do, we will add the powers, and here what I done, just I have separated that. Now this into x raised to the power b square into x raised to the power, this is now minus c square. Now this, okay, now x raised to the power c square into x raised to the power minus a square. Okay, now see here, now what I'll do, see here all the bases are same, but what we can do, now we will look at to the same powers with opposite signs. Like here a square it is here it is minus a square. So I'll bring these together. Now since both bases are same, we can add the power. So when I'll add, I'll get a square plus, in the bracket I'll write minus a square. You can just skip this step also, but still I'm writing one more extra step here. Now we will write this one. Okay, x raised to the power minus b square, and this is plus b square, into, we left with the c square. Now x raised to the power this minus c square, now this is plus c square. Okay, see here, now this is plus minus minus, right? So that I'll get a square minus a square. So it will get cancels. Here it will get cancels. Minus c square plus c square get cancelled. So what left? X raised to the power 0 into x raised to the power 0, this one, and this is x raised to the power 0. As we know that when the powers will be 0, the answer will be what? 1. For all we got. Now once you multiply all the 1, we will get answer 1 only. Hence it is proves that is LHS equals to RHS.